Thank you for tuning into this video from Cold Air Rentals. Today we're going to talk about understanding humidity and how that plays a role in preventing and mitigating mold. The first variable we need to understand is the temperature. The second is the amount of moisture in the air, and this is an actual amount, so it's an actual measurement. And the way you measure moisture or water in the air is in grains. And to give you an idea, 7,000 grains of water equals 1 pound. So that's a physical amount of water that's in the air. Then the next concept is to understand that there's a saturation point. So there's a maximum amount of water that the air can hold at a given temperature. So at lower temperatures, it can hold less moisture, and higher temperatures, it can hold more. So again, it's the maximum amount of water in the air at a given temperature. Then with this information, we can calculate the relative humidity. And the most important thing to understand is that relative humidity is relative to temperature. So it's the percentage of saturation at a given temperature. And the reason all this is important is because mold grows at 60% relative humidity. So this is a saturation chart. So what we're looking at here is the relative humidity in a very narrow window of temperature. So we're looking at temperatures between 70 degrees Fahrenheit and 85 degrees Fahrenheit. So at 70 degrees, the saturation point is 110 grains. As the temperature goes up, the saturation point, or the amount of water that the air can hold, also increases. And it gives us this line, which is our saturation point. This blue line would be 60% relative humidity. So what this is telling us, at any given temperature, this is where mold grows. So to take one more look at this, if you're looking at relative humidity, again, the way you calculate it is at any given temperature, you look at the actual amount of water that's in the air divided by the saturation point. So in this example, we're saying at 75 degrees Fahrenheit, we measured 100 grains of water in the air, and we know the saturation point is 131. So you divide 100 by 131, it gives us 75.3% relative humidity. So we would round that up to 76% relative humidity, and we would have mold grown. So next we want to talk about our equipment, and there's two pieces of equipment that we would use to try to remove the moisture from the air, and explain just very briefly how each of them work. So for the LGR dehumidifier, in summary and briefly, it's a cold air process that creates condensation. So it actually creates water that you have to get rid of and get out of your building. It follows the principles of air conditioning, which is a evaporative coil or a cold coil, and a condenser coil or a hot coil. The downside to this process is because it's a cold process, if the temperatures are too low, a LGR will freeze up on you, and it can never get below 35% relative humidity. A desiccant dehumidifier is a heat process. There's no condensation, and what it does is the air passes through a large silica wheel, and on our unit it's about 4 feet in diameter. And as the air goes through the silica wheel, it captures moisture, and it can capture up to 50% of the grains of water in the air at each pass through. As the wheel continues around, the unit introduces a concentrated heat stream that passes through the silica wheel and removes the moisture. So then we just direct the hot, moist air out of the building. And again, there's no condensation. And because of this process, it can get relative humidity can approach 0%. Please visit our website for more information at www.coldairrentals.com. Thank you and have a great day.
I think I have.
You should be able to print right here.